All right, let's get going. I think I got all the attendance, so everybody's mostly here. Missing a couple people, but they'll show up, I'm sure. Okay, so what is this? Day 4. Day 4. Today's when we really start to dig into algebra, which tends to scare some people because it gets a little bit, tricky's not the right word, but you got to remember a lot of little steps to algebra. And we're going to go through a lot of steps. My goal tonight is not to talk to you for a long, long time, because I want to give you a lot of practice where we'll just kind of try to crank through some of these problems. And I'll let you guys work on a lot of them and then go around and see if you have questions. But we do have to get the basics down for algebra in general. So we're going to talk about two things. We're going to talk about algebraic expressions and algebraic formulas. And they're different in the following way. Okay? Algebraic expressions involve variables. A lot of times in class we'll use x or y. Sometimes we'll use z or some other variables, or t for time, etc. You can use whatever you want. Okay? A variable just represents some different number. And in an expression or in a formula, if you see a variable, just means that's a number of some sort, and hopefully one that you'll be able to figure out what number it is eventually. Okay? So when we have a combination of variables, numbers, and operations. And operations are like addition, subtraction, multiplication, division, square roots, and exponents. All the things that we've been talking. And you can also throw some parentheses in there as well. Okay? We have the combination of variables, numbers, and operations makes an algebraic expression. You do not need an equals sign to have an algebraic expression. Okay? You don't need an equal sign at all. Okay? To evaluate an algebraic expression means that we find what the variables in it mean, or we get it to a point where we can't determine anything farther, rather. Okay? So what we are doing in this case, well, actually, I guess I said that a little bit wrong. To evaluate it means we have a number that we're going to plug in for those variables, and we're going to figure out what it means. That's really what we're going to do. Okay? So let me give you an example of this. All right? Let me give you an example of, I'll leave this up there for anybody else still copying here. Okay? So if we have 3 times x plus, in parentheses, x minus 2 squared, okay? And we say that's for x equal to 5. All we're going to do is plug that x equals to 5 in. Anywhere we see an x, we put in 5, and then we solve just like we would with the numbers we saw over the last couple weeks. Okay? So let's just do that. Hey, Christine. Okay, we're going to do that, and we're just going to plug in 5 wherever we see this. So I like to write everything down on the piece of paper. In tests and things, you should have plenty of space. And if you're doing your homeworks, you should have scrap paper and stuff to be writing all this stuff down. Okay, so we're going to plug in 3 times 5 plus 5 minus 2 squared. Once we do that, it's exactly like the stuff we've been doing before. First, we're going to do the stuff in parentheses. 3 times 5 plus 3 squared. Then we're going to do the exponents. And I'll also do the multiplication because I can right now. 15 plus 9. Right? And then 15 plus 9 equals 24. So that is the algebraic expression. No equal sign up here. We have a variable that we know the number for. We plug it in and we solve it. That's called evaluating an algebraic expression. Okay? Let's try a different one. Let's try the same thing. Well, we don't even need to try it, but the same thing with x equals to 4. You'd just plug in 4 here, and then do the same thing. And you'd get a different answer, because this is kind of the generic form. All right? As it stands here, you can plug any number in there and evaluate it. Okay? But when we say what it is, then we can plug in and actually figure it out. Any questions on that? Good. All right. So let's do another example. I'll start it down here. X squared minus 5x plus 6 for x equal negative 3. Go ahead and write that one down, and I'll do it right below it. Running out of space. It's OK. Do it up here. Pretty simple stuff. So far, so good. OK. Remember, algebraic expressions. OK. So this is, negative 3 squared minus 5 times negative 3. The tricky part, again, in these cases, the tricky part is saying, oh, negative 3 squared is not 9, or is not negative 9. It's negative 3 is the one in parentheses. It's kind of like parentheses there around the number. Then you square it. OK, that's kind of the tricky part here. I put the parentheses in there. Negative 3 squared is 9. OK? And the same thing here. Any questions on that? OK, good. All right. OK, so now we go from having expressions to actually talking about equations. An equation is just an algebraic expression, or I should say more than one algebraic expression, that has an equal sign between it. OK? An algebraic equation is two algebraic expressions with an equal sign. For instance, 3x plus 9 equals 3 times x plus 3. OK? Now, we wouldn't really, solving this is probably, we would solve this and we would get an answer we probably wouldn't like, as it turns out, but we'll get to that later. We're not going to actually solve that one yet. OK, but that's an algebraic equation. OK? We could try to, might as well do it. 3x plus 9 equals, see how the 3 is outside the parentheses here? We're going to use this a lot. What can we do to that 3 throughout here? Distribute it. It's a distributive property. 3x plus 9. Okay? So notice how this side equals this side. If that's the case, what if I made x equal to 1? Would that be 3 times 1 plus 9 is 10 equals 3 times 1 plus 9 is 10? What if I made x equal to 2? Same thing, right? This equation happens to be one where x can be any number. So that's a kind of a special one. There's also equations where x can be no numbers. And we'll get to those as well. But all right. So let's see. Here's another example. 3x plus 9 equals 15. OK, that's an equation. OK. By the way, this is called an identity. This is called a conditional equation. In this one, we can actually get the number for x. OK? We have to do a little bit of algebraic manipulation to do it. OK, I'll do that really quickly, even though we'll go over it in a little bit. 3x plus 9 equals 15. If I subtract 9 from both sides, you can always do that in equations. I get 3x equals 15 minus 9 is 6. And then if I divide both sides by 3, you can do that on both sides of the equation either, I get x equal to 2. The nice thing about these is you can always check them. You can always go back and say, all right, 3 times 2 plus 9 equals, with a question mark over it, 15, just see. 3 times 2 is 6 plus 9 equals 15. 15 equals 15. We're done. So you can always check these, which is good. And I'm going to give you plenty of time when you're doing tests and things to check your answers. Always check your answers. OK? All right. So algebra, what's nice about algebra, if you're the type of person that likes math, I guess, is that algebra is a good way to describe a lot of things in the world. OK? You can describe a ton of things in the world. This formula is just an equation that describes the relationship between two different things. OK? Whenever you see graphs and things, you're always thinking about algebra, because it comes down to that's how they make these graphs. OK? Finding the formulas, we do it by modeling. We do it by taking a lot of data, putting it in a chart, doing graphs, and then finding models for it. It all is kind of the building blocks for later mathematics, what algebra is all about. OK? Let's talk a little bit of vocabulary for a minute. Algebraic vocabulary. 7x minus 9y minus 3. OK? You can always rewrite these like this. 7x plus negative 9y plus negative 3. The only reason I'm doing that is to show you that in an algebraic expression, you can always break it up such that things are added together. And these things are called terms. OK, so that's a term, and that is a term. OK, not the x. The whole thing there is a term. OK, in this term, if you look at that term, 7x, this is called the coefficient. OK, and of course, this is called the variable. And whenever I say something like, oh, look at the coefficient of that, you can divide by the coefficient, I'm talking about just the number part. OK? We don't write the coefficients -1 and 1. We just leave them out. So if we add x minus y plus 3, this really is 1x minus 1y plus 3, but we don't bother. OK? Oh, and by the way, 7x here, what is the 7 versus the x? What are we doing to those two? Multiplying them. OK, so it's all basic stuff. Just wanted to make sure we got that down. OK, the negative 3 is the constant term. This is the constant term. The negative 3. Why is the constant term? There's no variables in there. It stays constant. OK. All right. So what we can do is we actually have these things called like terms, which means they have the same variable factors. OK, is anybody still writing these down? OK, give you a second. We have terms that are the same variable factors. So if you add 7x and 12x, those both have the same variable x, so they're the same factor. They're like terms. OK? If you have 7x squared and 7x, those are not like terms because they have the x versus the x squared. OK? I'll write those down. All right. Like terms. So let's do an example. 7x plus 3y minus 4x squared plus 12x, it's a plus, minus 8y. All right, lots of different variables and things in there, but we're just going to start looking at the like terms. Is there a like term to the 7x? Yes. Which one? 12x. OK, so those two are going to be like terms. And how about the y's? 3y and negative 8y. Actually, I should probably do it that way. Negative 8y, like that. What you can do with these is you can actually combine the like terms. So 7x and 12x, we just add them because they're added together, and you'd get, in this case, 19x. 3y and negative 8y would be negative 5y. And then we can't do anything with the negative 4x squared, so it's going to be like that. So that's the way we simplify those. Okay? Just the like terms. Even though you want to simplify the x ones, we have to do that in a different way. Like we're going to have to eventually solve this using a different method. But you can't just add or subtract those ones. Okay? Those are the things. Now, what we do is we can apply all of these algebraic expressions, like we can apply all of the properties of arithmetic, like adding and subtracting and dividing and multiplying, to all of these things. We just got to remember how to do it, which is the tricky part if you haven't done it in a while, especially. Okay? This is called a simplified algebraic expression. Algebraic expression. It's simplified because there's no parentheses, and all the like terms have been combined together. Okay? And by the way, this is the same exact thing as this. They're equal to each other because we haven't done anything to change anything in particular about it. Okay? All right. Still writing these ones down. We're going to do another one where we're going to actually simplify the equation. Okay? Remember your distributive rule. I'll give you that up front. Okay? Let's try simplifying this. Still writing this down? I'll put it up here, and then if you're still writing the next stuff, I'll do it. Simplify the following. 3 times, in parentheses, x squared plus 2x plus 7, in parentheses, 3x squared plus 2x. Okay? Simplify that. Good and tight. Did everybody get 24x squared plus 20x? I'm getting some questions, some concerned looks. First thing we did was we distributed the 3 through here, 3x squared plus 6x. Then we distributed the 7 to this one, 21x squared plus 14x. 7 times 2x is 14x. And then I just combined the like terms, 3x squared and 21x squared and 6x and 14x. If you get like confused by all the different things, cross things out as you use them. For instance, if I'm going to combine 3x and 21, 24x squared, and then 20, and I write it, and then 6x plus 14x, 20x, and just do that if you need to. Okay, it's just little tricks to do that. Okay, let's try another one. 3 times 5x minus 4 plus 2x. By the way, I turned on the AC the other day, earlier today. Still squeaks. I don't know why. I think they didn't really fix it. Whatever. For now, I'm not going to worry. We'll talk after. Okay, everybody gets 17x minus 12? If you're not getting this stuff yet, that's okay. This just takes some practice. Write it down, and then we'll practice this in a few minutes. Okay? All right. So that's this one. Let's try one more. Let's see. This one's a good one. 3x plus 5 bracket 2, heard a little, oh no, minus x plus 4. There's a couple different ways you can do this. Try to simplify this. Simplify this. I'll do it two different ways. 3x plus 10 minus 5 times x plus 4. If you didn't do it this way, that's OK. We'll do it the other way, another way as well. 3x plus 10 5x minus 20. One way to do it. I'm going to do another way as well. There's probably other ways to do it too. Anybody want me to go over this one? First, I distributed this. This is tricky. If you distribute the 5, you have to distribute it to both the 2 and to the negative x plus 4 here. And so I distributed. I did 5 times 2 and 5 times x plus 4. Then you have to just do another distributed. You have to do the 5 times the x and the 5 times the 4. But if there's a negative there, so it's going to be like negative 5 times x and negative times 4. That's why I got a negative 20. This is one of the ones where you're going to do this on the test. And you're going to go, I nailed that problem. But you're going to forget that little negative. And it's going to really annoy you. I will give you as much partial credit on these things as I can. Sometimes they say, well, the only thing that matters in math class is the answer. Well, it's the process. And arithmetic is important in this class, but it's not the end-all be-all. If you're doing the right steps, you'll do it. So I don't know. If this problem was worth, 3 points and you messed up on the negative 20, I'd try to give you one point off and call it a day. And you'll get 2 points for it, even though you got the answer wrong. I'll try that. I'll do the best I can. OK? You'll have to make it clear enough that that's where it is. The other way I did it was I said, fine, I can combine this internal part first, and I can do 2 minus x minus 4. Again, the minus here, this is really like saying 2 plus negative 1 times x, negative 1 times 4. That's why you got x minus 4. Okay, it's a little tricky, and you'll make that mistake unless you do lots of practice on it. Okay? Any questions on this stuff? We're going to do lots of practice, don't worry. All right. So that's the basics of algebraic simplification. But then but now we have to actually talk about equations, where equations come into play here. Okay? By the way, that was 6.1 in the book. Now we're going to do 6.2. Okay? Damien, am I going a little quick on that? You sure? OK. All right. We're going to do what's called linear equations. Linear equations, OK, in one variable. And we're also going to do proportions and proportions. Okay, linear equations in one variable and then proportions. Okay? A linear equation in one variable, is an equation that you can write like this. ax plus b equals 0. Okay? A has to be a real number, and it can't be 0. B has to be a real number, and you have to be able to have the 0 over there. Okay? That is a linear equation in one variable. We're going to stick to x right now as our variable, just because that's the way we always do it. But it could be some other one, and we'll get to examples where it is. But for now, x has to be in there, and x cannot be a squared or cubed or any other exponent. It's got to just be x by itself. OK? 3x plus 12 equals 0. Does this fit? There's your a. There's your b. You've got 0 in there. Fits. It's an algebraic. It's a linear equation in one variable. How about 2x equals 5? Not yet. But we can make it into one. So it is, but you got to do some rearranging. OK? This actually is exactly the same as saying 2x minus 5 equals 0. OK? Don't worry about how we did that quite yet. OK? But the point is that this is an algebraic or a linear equation in one variable because we can rearrange it to be this form. OK? You got to always be able to rearrange it like this. OK? And you normally can for the ones we're talking about. OK? How about, let's look at this one. Let's look at 4 times in parentheses x minus 3 equals 2x plus 7. I'm going to give you the answer so you don't have to go and do something we haven't quite talked about yet. But that is also a linear equation. You can generally tell because there's going to be one x term and there's no squared terms. You're going to see an equal sign, obviously. You're going to see a lot of other constants in there. And we're going to just be able to solve that. OK? One easy way to do this is to say, just subtract this whole thing from this side. Right? Well, first distribute the 4 through. So 4x minus 12 equals 2x plus 7. And then subtract 2x plus 7 from both sides. I'll put it in parentheses just so there, OK? Because that's going to be negative 2x minus 7. Negative 2x minus 7 is the same thing. OK, so this is going to be equal to 2x, let's see, minus 12 minus 19 equals 0, because that minus that equals 0. So then we can change this into this form if we want to. That's all I did was I just subtracted this whole thing from here. I know that looked funny the way I did it. We won't do it in one step like that normally. I almost always do it in 2 or 3 steps. But that's the easy way to think about it if you want to just go, oh, I can always turn these things into algebraic, a linear equation in one variable. OK. We have to do some solving of these things. And this is the part that people are like, oh, I hate that stuff, that algebra stuff, right? Here's what we're going to do. We're going to solve the equations by finding the value of x. In other words, find x. There's a little comic. Another joke. Another little comic on this is not this kind of class, but x, 4, and 20, and it says find x. And what's that? Yeah, and somebody goes, there it is. Right? It's like a blonde joke or something, but Anyway. All right, so we're going to be trying to find x that results in a true statement when you plug it back in here. Okay? And what we're actually finding are what we call the solutions. Okay, that one makes sense like regular English term, right? You're solving for it. That's a solution. You're going to find a solution. We also call it finding the root or the roots of an equation. Why do they call it that? Well, it's a mathematical term. The root of this equation is whatever x actually equals. Okay? For the example, we had 3x, let's see, where was it again? 3x plus 12 equals 0. Okay? Negative 4 is a solution because negative 4 times 3 times negative 4 plus 12 equals 0. Right? Negative 12 plus 12 equals 0. So negative 4 is a solution. The idea is we're trying to figure out how to get that negative 4. Okay? That's all we're trying to do. Okay, we also say that negative 4 satisfies the equation. It solves the equation. It's the root of the equation. And this is more for your homework than anything else. The set of answers looks like this. Negative 4 with those little curly brackets on it. Okay? In the homework and on some of the stuff we're going to do later today, they ask for the answer in this form. They're going to put the little curly brackets in there for you on the homeworks, and I'm not going to expect you to ever do this on the tests or anything. Just know this is what they do. You can also have, I think I did this the other day, where you have the set that looks like this, and my curly brackets aren't very good, but that means the null set, which means it does not exist if the answer doesn't exist. Or you can also say, let's see, I forget exactly how it goes. It's the curly bracket, and then it's like, what is it? X for all x, or something like that, right? Meaning that it's every answer, like the one we had before, where you could plug in any answer and it would solve it. Okay? Don't think that's exactly how they stated on there. I forget. You'll see it on there if the answer comes out that way. Okay? All right, we're getting there. All right. Two or more equations that have the same solution are called equivalent equations. That makes sense. Okay? So we could say 3x plus 12 equals 0 is equivalent to 3x equals negative 12, or x equals negative 4. They are all equal to each other. Why? Because they all have the same solution. In this case, x equals negative 4. Well, negative 4 is equal to x. In this case, negative 4 equals x, and negative 4 times 3 is negative 12, so that's equal. And then we did this one already as well. Okay, we just call them equivalent equations. Okay? All right. Now, to solve equations, to solve them, okay, what we do is we convert the equivalent equations until we get a solution that's obvious. This is considered an obvious solution. Why? Because it tells you the answer, right? So if you go through a conversion process of converting this not so obvious, unless you're like really good at arithmetic or whatever, to this, which is obvious because it tells you what the answer is, that's called solving the equation. Okay? And you don't change the solution. Remember, this solution is the same as this solution is the same as this solution set. Okay? All right. We can do this by a number of ways. We can use multiplication, we can use addition, we can use division, and we can use subtraction as well. You do all these operations. The key is that if you have two equations or two sides of an equation, you can do the same operation on both sides and not change anything. Okay? We've done this a couple times already for other ideas, but that's the key to this whole thing. Whatever you do on one side of the equation, you do the exact same thing on the other side of the equation, and you're good to go. A couple things you can't, well, one thing you can't do, you can't divide by 0. We already said we can't do that. You can't divide by, that would make things like, let's see. Well, I don't have a good example. But you can look up online how to make 1 equal to 2 using algebra. What they end up doing is they divide by 0 in kind of a tricky way. And you go, oh, 1 equals 2. And the reason is that they divided by 0. So you can't do that. Otherwise, you can do pretty much anything else. You also don't want to multiply both sides by 0, because then you'll have 0 equals 0, and that doesn't help you either. OK? All right, here's an example. All right, our first algebra example. X plus 5 equals 12. 12 seems to come up a lot here. X plus 5 equals 12. Fairly straightforward. We want to get x by itself, so there's a solution that's obvious. Subtract 5 from both sides. And you should try to do this as step by step as you can. I tend to skip steps when I do this stuff, and then I get it wrong. X plus 5, so we're going to do this. X plus 5 minus 5 leaves x by itself. 12 minus 5 gives you 7, and we're done. OK? Our answer would be 7, the set that includes 7. OK? Let's try another one. How about x divided by 5 plus 4 equals 6? This one's a two-stepper, I would say. Step number 1, subtract 4 from both sides. We're left with x divided by 5 by itself equals 2. And then step 2 is what? Multiply by 5 on both sides. So I'm just going to do it like this. 5, 5. And those two are going to cancel out. We're going to be left with x equals 10. What do? We check it. 10 divided by 5 is 2. 2 plus 4 is 6. We got the right answer. OK. All right. We're going to go through a few of these, and then we're going to launch you out into the great world of solving these on your own. All right. How about this one? 3x plus 7 equals 5. This is pretty much almost the exact same one as the last one. Minus 7 on both sides. 3x equals 5 minus 7 is negative 2. You can use your calculators for these things too. What's that? No, I want it in fraction form. Yeah. So you're going to divide both sides by 3, and you're going to be left with x equals negative 2/3. Okay. There are probably calculators out there that actually do these whole things. You plug in this, and it goes and comes up with x equals negative 2/3. But you didn't hear that from me. You can't use those on the test. Sorry. Okay. All right. Any questions on that one? Let's look at this one. How about 3 times in parentheses x minus 6 plus 5, it gets a little harder here, equals 7x minus 4. I know I'm going to have to wrap around to the top of the board on this one. Maybe. Does your program do that? Great. Well, it's a good way to check anyway. All right. So here's how I would start to solve this. There's lots of different ways to solve this. I would start by distributing the 3 through here. 3 times x minus 18 plus 5 equals 7x minus 4. Then I would combine all the terms that are the same on both sides. So now I'm left with 3x, and these two I can combine. Negative 18 plus 5 is negative 13, equals 7x minus 4. Then I'm going to go back up to the top of the board here. The next thing I would do is I would say, OK, let's start getting either the variables on one side or the constants on one side and pick a side. It doesn't really matter which one. You may have to divide by -1 if you do it wrong. But let's just say we're going to get the variables on this side. So we want to get rid of the 7x over here. So you're going to subtract both sides by 7x. So minus 7x over here and minus 7x over here. I'm wrapping up to here. 3x minus 7x is negative 4x. I'm going to leave everything else the same, equals negative 4. Now it's getting to be a little more straightforward here, like less craziness. Okay? Now I'm going to deal with I've got all the x's on one side. I'm going to deal with the constants now. I'm going to add 13 to both sides, plus 13. Okay? And I'm going to get negative 4x equals 9. Okay? And now I need to get the 4 or the x by itself. So I'm going to divide both sides by negative 4. And I'm going to be left with the negative 4's cancel out. I'm going to be left with x equals negative 9/4. And the negative, just because it's on the bottom, doesn't really matter. It's going to be either on the top or the bottom. Doesn't matter. And that's how you solve that one. There are other ways to do it, again, where you could subtract the whole thing here over there. I like to do it this way. It seems a little more straightforward to me. But that's up to you. Question?
When you're doing, for simplifying reasons, negative 9/4, it's OK that it's improper?
It is fine that it's improper, yes. Yep. Yep, no worries at all. You don't need to change it into, what would that be, 2 1/4 or negative 2 1/4 or whatever? Yeah, you wouldn't have to do that. Nope. No. I'll never really. I don't like mixed numbers because they're a lot harder to kind of conceptually deal with anyway. So you can put it. You could if you want. I don't really care. But don't go through the extra work to convert it. OK. All right. OK, let's try another one. Everybody get this down? OK. Let's try another one. Let's try 12x plus 10. 12x plus 10 equals 5x plus 66. I'll start to write down the way I would do it. Whoops. Too far there. OK, this is how I did it. And you can do it a different way. If you wanted to, you could take the whole thing and subtract it. It's up to you. I like to do it this way to make it one step at a time. Subtracted 5x on both sides. Ended up getting 7x plus 10 equals 66. Getting rid of the 10, subtracted 10 from both sides. And then ended up with 7x equals 56. Because I need to get rid of the 7, I divide both sides by 7. Ends up with x equal to 8. And then I checked it, by the way. I just plugged in what I got here, 8 here and 8 here, did both sides and found out that 106 equals 106. So I'm happy. Okay. Any questions on that one? All right, let's do another one. See if you can figure this one out. I'll start it up here. 4 times x plus 1 minus 5x equals 5 minus, in parentheses, x plus 4. Some of you guys might have gotten 0 equals 0, or 1 equals 1, or I don't know, something equals something else that's both a constant. If this happens, what do we know the solution is? I wrote it down before. Actually, I didn't. This is the way you should write it. This says any value of x works. And you can test it. And you can say, what if I put 1 in there? 4 plus 1 minus 5 times 1. 4 minus 5 is negative 1. 5 minus, what did I say, 1? Yeah. 1 plus 4, oops, sorry. 5 minus 5 is 0. 5 minus 1 plus 4 is 5 equals 0. 0 equals 0. So it works for any number. Okay, so this is one of those tricky ones. Try this one. 3x minus 7 equals 3 times x plus 1. What's the problem with this one? Can't be solved. Yeah, this one, the problem with this one is any number you try will not make this equation equal. It's impossible. Okay? If you're a math teacher and you try to make up problems like this, you got to watch out for that sort of thing. If you're trying to make up problems that can be solved. Because you put x's on one side, x on the other, and if you don't do the solving, you don't realize, oops, I accidentally made it, so it's a non-solvable equation. So this is the one where we say there's no solution because that negative 7 is not equal to 3. And I guess that's the wrong way to do the not. Not equal to 3. And therefore, you've got to say that the solution set is this null set. Okay. Zach, you missed an important one. The null set. We ended up getting negative 7 equal to 3. And it ended up because we goofed on that one. Okay. All right. That's a lot of stuff. I've got 1, 2, 3, 4 more pages of notes before we can do the practice. Let's take a break now. Come back at 15 after. And then we'll keep going. All right. OK, so let's crank through these last basic algebra steps here, and then do ratios, and then we will get going on this worksheet thing that I have, and then I will just walk around and help you guys out on that. OK, the next thing we got to talk about is how do you deal with fractions in equations like this. There's a couple different ways you can do this, as there always seems to be. One way is to do it just like everything else. Constants, you could actually move the constant over here. You could subtract 3 from both sides. Then you have to do 29/5 minus 3, which means convert 3 to a fraction, blah, blah, blah. There's a slightly easier way to do this, which I'll show you how to do it. And it actually gets rid of the fractions, boom, right off the bat. What you do is you find the denominator that is the least common denominator between any of the fractions. OK? There's just one fraction here, so this makes it easy. We're going to take 5, and we're going to multiply all the terms by 5. In fact, we're going to multiply both sides by 5 in this case. And the reason I say both sides is because if you didn't do it this way, you'd end up with the wrong answer. You have to distribute the 5 through all the terms. OK? So that means both terms. But 5 times 2x divided by 5, the 5's actually cancel out, which is really cool because you're left with 2x. 5 times 3, because we're distributing here, gives you 15, equals 5 times 29/5. Those 5's actually cancel out as well, and you're left with just 29. Now you've got an equation that's very easy to do. OK, you started with this. Now you've got this that people in here can actually do in their heads, because it's pretty straightforward, right? We're going to subtract 15 from both sides. Right? We're going to be left with 2x equals 14. And then divide both sides. I always skip this step because I do it in my head. Divided by 2, x equals 7. OK? You want the long way around? That's fine. If you want to do it the long way around, no, you won't get any complaints from me. It'll just be a little more subtracting and adding of fractions, which is just kind of a pain. OK? Sometimes the numbers get a little big when we do this. And I'll show you the next one where that might be the case. I'll leave the bottom there for anybody copying down. The next one we're going to look at is 2x over 5 plus 3 equals 4/7. Anybody know that off the top of their head? Mr. Chance. We went over this a little before. 2x over 5 plus 3 equals 4/7. OK? You could go do it the long way around again if you want to. But the easiest thing, I think, is to do this. The least common denominator between 5 and 7 is just going to multiply them together. That's the easiest thing to do. You get 35. So if you multiply both sides of this by 35, like I said, it ends up being a little bit longer. You'll see that some things cancel out and it makes it really easy. In fact, all the fractions go away. 35 times 2x over 5. When you divide 35 by 5, what do you get? 7. So that's what's left over. 7 times 2x gives you 14x. That part, we could probably break it into a couple more steps. But what you're doing is you're saying, what cancels out here? Well, 35 divided by 5 is 7. 7 times 2x is what you're trying to do. 14x. You do have to do the 35 times the 3, which is 70. No, sorry, 105. Make sense? 105? I was looking at the wrong page. 105 equals, you do the same thing over here. 35 divided by 7 is what? 5. 5 times 4 is 20. So you're left with 14x plus 105 equals 20. And then you can do the same things you'd do before. Subtract 20 from both sides. All right. Oh, actually, I guess we would probably do it the other way. You could do it that way. But how about this? Subtract 105 from both sides. Right? So you're left with 14x equals negative 85. Then divide both sides by 14. And you're left with x equals negative 85 14ths. On the homework, they're going to ask you to reduce these. This one actually doesn't reduce. On the tests, I won't make you reduce them. Okay? Leave it like that if it is. I mean, if it's an obvious one, just reduce it. I mean, if it's, right, let's see, 4/12 or something, right? That's a pretty easy one to reduce. I'd probably say, come on, just reduce it, right? 1/3. But otherwise, just leave it like that. I multiplied 35 times 3 because we're multiplying the whole thing by 35. Right? This one, if I multiply 35, what you do here is 35 times 2x, you actually get 70, this is what you were saying, Tim? 70x over 5 for this part. But then you know 70 divided by 5 is actually 14. You could do that too, by the way. You could do it this way, leave it as 70x over 5, and then just divide 70 by 5 and get 14. It doesn't matter to me. There's two important parts to this. Important part number 1, knowing steps that you can do to move forward to solve the problem. And number 2 is doing them correctly and getting the right answer. There are multiple ways of doing those steps. I'll try to give you the ones I think are most intuitive or most easy to apply. But if you want to do the other way and you can do it right every time, go right ahead. Okay? No worries. You won't get any complaints from me. OK. Ratios. Okay? Ratios compares quantities by division. Okay? A ratio compares quantities by division. Okay? So, at one point or another, let's say there were 850 soldiers here at Camp Lemonnier. And let's say there were 700 sailors. I'm not worried about the Air Force. No offense to the Air Force people. 850 soldiers and 700 soldiers. Okay, the ratio is 850 divided by 700. That's the ratio, which when you actually do the divide by, well, the first thing is you can divide by the 10 there. So you get 85 divided by 70. And then 5 goes into 85, 14 times? And 5 goes into 70. Whoops, I did it backwards. Actually, it really doesn't matter. You could do it this way. Let's do it this way. It's fine. 85 divided by 70 is, 85 divided by 5 is 17. 70 divided by 5 is 14. The ratio of soldiers to sailors is 17 to 14. Okay? That's the ratio. And by the way, I love Marines. My cousin's becoming a Marine. I sent him a letter, and I put my rank on the outside, and supposedly the Marine Corps drill sergeants will crush him for that, but hopefully he'll be all right. Anyway. OK, so a proportion is different from a ratio. A proportion is actually an equation of ratios. So A over B equals C over D is a proportion. Okay? That's saying you've got A over B equal to C over D. For instance, 1/2 equals 5/10. Okay, that's a proportion, and they're equal to each other. Okay? The nice thing about proportions is we have fancy ways of dealing with them that makes it easy to solve if we have ratios in there. Okay? So if you have a over b equals c over d, okay, what would the common denominator be for these two? B times d. So if we multiplied b times d to both of these, this one's going to cancel out b, and you're going to be left with a times d. And this one's going to cancel out d, and you're going to be left with b times c. And that's also an equivalent statement. All we've done is multiplied the same number to both sides, b times d over here and b times d over here. And we're left with a times d equals b times c. Let me rewrite it again. A over b equals c over d. What we've done is we've multiplied that and set them equal to each other. This is called the cross product principle, otherwise known as cross multiplication. And it makes getting rid of fractions really easy if they're in this form. Okay, because now we have a times d equals b times c. It's the easy way to do it. Okay? And it doesn't matter which side you put the equals on. You can put, doesn't matter, because they're going to be the same. Okay? That's called cross multiplying. If you have a problem that involves a variable, it makes it easy to solve it. So let's do one. 72 divided by x equals 8 divided by 5. Okay? You could multiply both sides by 5x, blah, blah, blah. Easy way to do it, cross multiply. 72 times 5 equals 8 times x. Okay? 72 times 5 happens to be 360 equals 8x. Divide both sides by 8, and you're left with, I'll move the x on the other side just because it's standard, x equals 36 divided by 8, or 360 divided by 8 is 45. Okay? And if you plug this into your calculator, 72 divided by 45, you get some answer. And hopefully, if you plugged in 8 divided by 5, you get the same answer. Good way to check it. Cross multiplication will always work for equations in this form. You just have to be careful if the equations involve a little bit extra. So like 12 divided by x minus 5 equals negative 18 divided by x. You can still cross multiply, just don't screw it up. Okay? It's the whole thing you're multiplying by. 18 times x minus 5 equals 12x. Thank you. Negative 18 times x minus 5 equals 12x. Okay. All right, so now we distribute the 18 through. You don't have to. In fact, yeah, it's probably best to. I would distribute the 18 through here, negative 18 through. Negative 18x plus, what's 18 times 5? Let's see. 90. Thank you. Okay. And it's, remember, negative 18 times negative 5. Don't forget that. So it's going to be plus 90. Okay. Equals 12x. Let's see. Let's do this. Hey, coming in a little late tonight, huh? Grab your seat. No worries. Let's see. OK, so then we have negative 8. What's that? Work every day, yeah. All right, negative 18 plus x plus 9 equals 12x. So let's see. Let's add 18x to both sides. Plus 90 equals plus 18x. We're left with 90 equals 30x. Divide both sides by 30, and x equals 3. And you can check it. Again, plug in x equals 3 into either this one or this one. Doesn't really matter. The best one is to plug it into the top one. 3 minus 5 is negative 2. 12 divided by negative 2 is negative 6. Negative 18 divided by 3 is negative 6. We're good to go. Always check your answer if you can. And I'll give you enough time to check your answer. Okay? All right. Let's do one more example. Let's say you had a house. It was $220,000. And you have to pay property taxes, because unless you live in Djibouti, Uncle Sam's going to get his money. Okay? And the taxes are $1,200. $1,200 on this house. Somebody else, probably an accountant, has a $320,000 house. We want to know, for the same tax rate, what the taxes are going to be. Okay? This is where we just do a ratio. Okay? The ratio of taxes for this house is going to be the same as the ratio of taxes for this house. And so we could say 1,200 divided by 220,000 equals some value of taxes that we don't know divided by 320,000. Cross multiply. 220,000 x equals 320,000 times 1,200. My first thing on this, what I would do is I would try to simplify this a little bit. This is not part of the thing, but the easiest way to do this is to say, if this has 2 zeros, and this has 2 zeros, and this has 2 zeros, I'm going to cancel out all those zeros. Actually, that's not true. I can't cancel out the last two. Don't pay any attention to what I just said. I guess you could, but you'd have to do it with the x as well, so it wouldn't work. So let's see. If you do this on your calculator, this becomes 384,000. Is that right? Doesn't seem right, but I guess it is. 384. That doesn't seem right. Yeah, I guess it is. 384,000,000 million then equals 220,000 x 220,000 x. Now you can cancel out some zeros. 1, 2, 3, 4. I can cancel all those out. 1, 2, 3, 4 if I want to, and say 22x equals 380,000. Divide both sides by 22. And you end up with x equal to 1,745.45, probably repeating. Is it repeating? Well, Uncle Sam doesn't care about the repeating part. In fact, Uncle Sam doesn't even care about the 0.45. You pay your taxes and you get to within the nearest dollar, they're cool with that, right? So we call this $1,745.45, or just 1745. 1746 would work too. Well, I guess rounding down would be 1745. Okay. What's that? Is it like 10%? I don't know. What is 1,200 divided by 220,000? Do that on your calculators. You got it. And that would tell you, and then multiply by 100, and you get the percent. Okay? All right. So we are actually through with the stuff I'm going to talk at you about tonight. Okay? I gave you a sheet that's like kind of like 10 pages long. It's got all these sorts of problems on them. Okay? I would like you to work on these, and you can work with your neighbor or by yourself, but I'll go around and work on them. And I tell you what, if you get done with these, you're welcome to scram. You don't have to finish them all off either. But if you, I want you to just practice these and get as much help as you can. Okay? Remember one thing. The test is on next Saturday, the first test. I have a practice exam that I will hand out as well. So So you can take this in home. I won't grade it. You want me to put the answers online? I tell you, I'll either email or put the answers online. I forgot to put the answers on here. So I'll do that. And then I will, if you don't see the answers by like Wednesday or whatever, email me. And I'll shoot them to you online. And that'll do. And then Thursday, we've got, of course, the practice session as well, or the tutoring session if you want to come to that as well. That's up to you. OK? I'll hand these out, and let's get going on this sheet. And if you want me to do something for the whole class, too, I'd be happy to. If a couple people ask me about the same problem, I'll do it.